Hello everyone, this is Richard from SimScale. I welcome you to today's webinar on microclimate simulation for architects and engineers. So I'm Richard Zögerschuler and I'm product manager at SimScale for everything related to AEC topics, so architecture, engineering, and construction. And today with me are Darren Lynch. He's a senior application engineer at SimScale, and he's presenting to you later in the webinar a live demo of our tool, the SimScale platform, and shows you some details about wind comfort and microclimate analysis, how it can be set up and evaluated using SimScale. And as well, later in the webinar, Ajit Kumar, another senior application engineer, will join us for a quick Q&A session. And this brings me to the next topic. So we'll present the next half an hour our solution and some insights on wind analysis in urban environments. And whenever there comes a question to your mind, please use the functionality of the tool to post your questions. And we'll spare a couple of minutes towards the end to try and answer all of your questions. Okay, without further ado, let's now start with the actual content. So today's application is about microclimate simulation, and specifically, we're mostly talking about urban wind analysis. We'll show you how SimScale makes CFD analysis accessible for architects and engineers, so they can perform microclimate and wind comfort analysis using cloud-based technologies. We'll show you how with SimScale, designers can benefit from early stage design tools, especially that can help them to quickly and also accurately evaluate designs and proposed designs for various applications. We can analyze general wind studies and building aerodynamics using SimScale, see different wind effects around buildings, downdrafts, acceleration effects, and so on. We can also use automated pedestrian wind comfort and safety analysis for a specific site to analyze the yearly pedestrian wind comfort. As well, what can be done on SimScale is very easily to compare different climate scenarios for high winds. So we can have a look into the future and see how a specific design will perform with future changes in the climate and how this impacts the comfort of pedestrians and especially the safety around high-rise buildings. And on top of the wind comfort analysis, we can also do an outdoor thermal comfort analysis. So taking into account radiation, thermal effects as well, to also inform about the thermal effects and behavior and how people will feel on a pedestrian level around buildings and in larger cities. So for the ones amongst you who haven't heard yet too much about SimScale, I want to quickly introduce you to what's specific about SimScale, what we are standing for, what we're doing. So we're at SimScale, we want three things. We want you to simulate early and more and ideally now. Right? So we think that every designer, architect, and engineer can benefit from simulation, and they should be able to do so without having many obstacles to overcome. So we basically do this through three items. So we make the simulation accessible at any scale. So with SimScale, you run large-scale simulations with dozens of millions of cells directly via the browser on your computer. You don't need any large hardware installation at your site. We enable engineers to simulate without compromises, so you don't have to simplify a lot of the geometries to levels where you're not sure anymore if the actual effects are still visible with the simplified design or not. And we do so by delivering best-in-class solvers, UX, and support. So we have a specific solver technology that allows us to run these types of simulations in a very robust way. The user experience on SimScale, as you see later, is built from ground up to focus on user experience. So it has an intuitive way to set up simulations and evaluate the results and make informed design decisions. And in case you still have questions and are new to simulation in general, we enable through a live support inside the platform to really get started with simulation quickly, overcome obstacles, and get to your results as fast as possible. Okay, and now I'll hand over to my colleague Darren, who will be showing you how this can be done on SimScale on a practical examples, and introduce you to some of the additional concepts that are important when evaluating urban wind.
Thank you for the introductions. So firstly, what do we actually mean by a cloud-native engineering simulation platform? So this is actually SimScale. I've got open now, and what it's actually doing is it's just running in a web browser. So this is Google Chrome running SimScale. You don't need to have anything locally installed. You don't have to have any amount of local hardware to actually run these simulations. Everything is handled, of course, on our cloud-native platform. And you would log in remotely, like you would any other online service, username, password, or single service authentication. Now, from the point that you log into the SimScale platform, you upload your geometry, you've got actually no need to move out of this cloud-native platform at all. So everything from pre-processing, setting your simulation up, viewing results, is all handled within this native browser environment. And you can actually see the example that we're going to be talking about today on screen here. We're looking at some of the key results that we see in this beautifully large viewer. And on the left-hand side in general, we've got this simulation tree, which is where we would do the geometry uploads, set up our simulations. On the right-hand side, we've got live support. So if at any time you've actually got questions to ask us as you're trying to use SimScale, maybe you want to be pointed towards some documentation, maybe you've got a question about a certain part of the simulation that you're trying to set up, then we've actually got live support here to assist you in any part of the SimScale platform where you're having troubles. Now, let me move back to the slide deck and we'll start our introduction about the case that we've actually got on screen at the moment. So, today we're going to be looking at a scenario in downtown Boston, near Boston Common, where we're going to be looking at a more of an early stage site analysis type simulation. Now, large proportion of our user base for pedestrian wind comfort is using this for early stage designs, and really what they're trying to do is they're trying to optimize the site layout, the orientation, maybe the building's height, to understand what the best or the most optimal comfort is going to be in areas that could become problematic at a later time. So really here, finding out things early rather than later and mitigating or improving the site's comfort is the objective. Because really at an early stage you've got more opportunity to correct any issues than you would at a later stage. And this particular model came from bostonplans.org. We used 4 of the tiles from there, and we centered the CAD on the site that we were trying to optimize, and actually on the right hand side you'll see that's in magenta. And the geometry was not cleaned. It's important that I emphasize that, but we did do a bit of topology preparation that you can actually see there with the rings in the topology. That's the only changes we made. Now, really we wanted to just spend a few minutes here to understand what is meant by early stage in pedestrian wind comfort, and more importantly what it means to our customers. So mainly what we observe is the customer is at an early stage where design iteration is possible and can be informed by simulation. Typically the site geometry is low detail, as it's prior to any detailed design happening, so this would be normally prior to any work done in Revit or BIM, for example. The contextual geometry could be simple or it could be complex, so at an early stage we wouldn't want to spend too much time cleaning and preparing geometry, so we might actually decide to go to a supplier, like we have in this case, and bring in the contextual geometry, but we don't want to invest too much time to make that proper, and that's what I mentioned in the previous slide. The faster the analysis can be done, the more insight can be observed and the more exploration can be done, so we can iterate much more quickly to obtain these insights And therefore, the more insights we can do at this early stage in a short period of time, surely the better the result in the long run. And usually the end user is typically involved in design and not necessarily high-end simulation. They will come with a less amount of experience than some of our other typical users. So with these requirements from our customers for a PWC or pedestrian comfort solution at an early stage, how do we fit the bill? How do we fit that typical requirement from our customers? So we actually fit it in quite a few different ways. So SimScale's pedestrian comfort analysis type is robust to geometry, which means that regardless of the complexity of the topology or the context, you can upload it to SimScale as an STL file format and we will handle that robustly. SimScale's PW solution runs in the cloud. This inherently means that we can run many wind directions in parallel, speeding up that process, but also our pedestrian wind comfort solution is on a GPU architecture from Pacefish. Now this means that most solutions are returned within 30 minutes to 2 hours, which is incredibly fast for this kind of simulation. When I say this kind of simulation, it's a high fidelity transient simulation using the Lassos-Boltzmann method. Many designs can be tested at once, so building on from the advantages of being in the cloud, if you've got many designs that you want to try out, then you can actually run them all at once. If you've got a design exploration of maybe 30 different designs that you want to just test to see which gives you the closest to a good starting point, then you can absolutely do that. And finally, the user experience is created to give non-expert users the ability to get qualitative results, whilst giving the customization needed for more advanced users. So I'm going to show you this later in the SimScale platform, and I think you'll agree that we have a very simple 3-step process to actually setting up these simulations to give you some good results out. So we've discussed why we're a good fit to a requirement that is defined by our customers in early stage pedestrian wind comfort. But what is it that we're getting out of these analyses? How can we use these results to actually make decisions? And that's what the next few slides is going to talk about. So the first key result that we get out of these pedestrian comfort simulations is pedestrian comfort and pedestrian safety. And what this is essentially a breakdown of what pedestrians would be comfortable doing in what locations. So you can actually see on the image on the left, this is our case that we're talking about today, where people would be comfortable standing, walking, either in a business manner or a pedestrian manner. So if you're walking with a mission, then that would be business walking. If you're more casually walking, then that would just be pedestrian walking. But also it shows you where people will be uncomfortable and perhaps, if you're looking at safety, unsafe in some locations. And you can see what all this means in terms of the breakdown of the colours. So all the categories in comparison to what activity a person would be doing here and what they would be comfortable doing. So it's important for us as a user to define what areas would pedestrians be doing certain activities and therefore draw conclusions from that. This isn't the only thing we're going to get out of simulation. It's very good to understand where people are going to be uncomfortable or not comfortable for a certain activity, but then it's our job to really understand why they're not comfortable for that activity so that we can make sure that we can improve the space for that purpose. And that's when we move on to the next slide. So building off of pedestrian comfort, which I've now got on the top right, how can we use individual results to really determine what's happening at a local level? So in this case, what we're going to do is we're going to use the 3 main wind effects to identify how a building or site can be improved to increase the suitability of that design for the activities that people need to do. And we can do that by firstly inspecting the comfort plot, as I mentioned, and then correlating them to the wind speed results that I've got on the left hand side. And once the user can actually understand the causes, he can iterate the design, or they can iterate the design and retest it. So the 3 main effects, we can actually see them on our case that we're looking at today. Downwash, So you can actually see this arrow that's really pointing at how that flow is moving. You can see the streamlines that is going to be pushed down the building, and that's going to impact the pedestrians at the pedestrian level. We can see the cornering effect. You can see a different wind direction I've taken, that you can actually see a very dominant cornering effect happening here, where you've got high speed regions but also a low speed region here happening around that corner of the tallest building. And also channeling effect. So when wind blows down a corridor or a wind channel and actually increases the wind speeds and affects comfort. So those are the three main effects. So let's quickly look at how we can use those effects to really mitigate and improve a design or make a design iteration. So here we've got a problem. Okay, so we've got a prevailing wind direction that's coming from the west in this case. The problem is that we've got two very large uncomfortable areas there that is caused by the site that we've designed, the buildings that we've designed, and we need to improve that. What is the cause? So we can go into our prevailing wind direction, look at the three-dimensional flow fields around that building, and really analyze why we're getting these uncomfortable areas. And if we were to rotate around this building, we can actually see that the wind is coming from up high, that's going quite fast over the buildings, it's being drawn down to pedestrian level, and it's whipping around the building. So this would be looking like that on the top-down view. How can we improve that? So in this case, I went for the most simple solution I could. If I introduce a glass canopy that's at roughly the height of the surrounding buildings, what I can actually do is reduce the downwash effect. So I can make sure that the downwash effect comes out at a higher level than the surrounding buildings than going down to pedestrian level. Does it work? Well, that's what design iterations are for. And if we look at the two different designs side by side, you can actually see how much of an impact this has had. So on the left hand side, design 1, without the glass canopy. On the right hand side, we can see design 2 with the glass canopy. So that design iteration worked. That was a good method. What I could have done is I could have changed the building's shape, orientation, heights, for example, until I get the same effect. But of course, being able to iterate your design means that we don't just take the worst parts and walk away happy with those results. There is still more work to be done, and we can go away, analyse this area separately, and make further design improvements. So this is the bit of the presentation where I get to actually show you the SimScale platform live, doing the task that we set out to do. So I'm starting this demo in the results, and what I've got here is comparative view. Now I should note here that the compare functionality in the post-processor is in beta view, beta access. And what we're having a look at is a comparison between design 1 on the left and design 2 on the right with the glass canopy. And we're visualizing three-dimensional results, so the streamlines or the direction or flow pattern in 3 dimensions around the buildings that we're trying to design. And the key thing that we should be looking out for here is the downwash effect. So the downwash effect you can visibly see here is flow is coming up to the building, it's being washed down by the larger building, and on the left hand side on this design 1 we've got flow going down to pedestrian level and exiting outside. On the right hand side, design 2, you can actually see that no flow gets down to pedestrian level, and in fact you can see that any high speed flows exits a lot higher than the original design. Now, if we wanted to then go and compare what this looks like in terms of pedestrian comfort, or how this improvement affected pedestrian comfort, like I showed in the presentation, we can actually exit out of this visualization. So I can come out of compare. I can scroll along to my design 1. I can select the comfort map. I can load it into my viewer. And here we can actually choose what comfort map we visualize. At the moment we're using the Lawson criteria. And from here what I can actually do is I can go to the compare functionality. I can select which run to use. I'm going to use the design 2, run 1. And this puts me into split screen again. and we can actively look from any view, because the views are synchronized together, what impacts these design changes had on the comfort, like I showed in the presentation. And you can see mainly these two large patches on the right hand side there have been removed in this design iteration. And as I mentioned, we can rotate and move around our design as we need to actually understand what the results mean. So, how do we set up one of these simulations? What are the key steps? How long does it take me? So that's what I want to show in the next couple of minutes. So I'm going to come out of compare mode, and I'm going to start a new simulation. So I'm going to create a new simulation called the pedestrian wing comfort analysis. Now, what we usually describe this as a simple three-step process. So the user is asked three basic questions that we expect them to answer, and after this process, the user can start a simulation, iterate simulation setups, and also use this as a template for any further design iterations as well. So the first thing that we do is make sure the geometry we're using to set up the simulation is correct. So I'm going to actually assign design 1 to my geometry. I'm going to rename my simulation to design 1 demo. And we're going to start the simulation setup process. So the first thing that we need to do is discuss the region of interest. So the region of interest is put a ring around the site, the building, or the area that you wish to receive results on. This does quite a lot behind the scenes, but essentially it's going to be how we define that result disk that we saw in the presentation. Here, the default 300 meters is absolutely fine. If we wanted to adjust the centering, then we could, and also the height if we wanted to. So that's the first step done. The second step is actually to find where you are. Now, we could go onto an online source and find some wind data, or we can actually use wind data from our connected service, Meteor Blue. For the purposes for this demo, I'm going to just use the Meteor Blue connected service to import wind data. Alternatively, you could get stat files from sources such as climate.onebuilding.org, for example. So I'm going to import this wind data after defining my location. You can see that the map's updated with my location. Import wind data, and my windrows gets populated. Now from here I can actually choose the number of wind directions. Maybe I'm at an early stage, maybe 4 directions is okay, maybe 6, maybe 8. It's up to you to decide that. We can additionally define what the exposure categories are. So if, for example, to the north it's dense urban area, which is quite likely in this case, we can actually change that to urban area. If, for example, to the east we've got open sea, which could also be possible, depending on whereabouts in the city you are, you can define that as well. And we can save that. So that's the second step completed in setting up the simulation. The third and final step is to actually define where pedestrians are going to be standing. So in this case, it's as simple as selecting the city region here. I could, for example, select other surfaces that could represent terraces or balconies, if you wish to. And all of these complicated surfaces, if they're hilly, for example, or take shape of the topology, will be vertically offset by the height that you define here, which in this case is 1.5 meters. And we can save that. So in terms of basic simulation setup, we are finished. We've got those 3 steps defined. Now we can actually start a simulation, and this will return to us the estimator. It will tell us how long the simulation is going to take, how many compute resources it's going to consume, and also what the minimum cell size is. And at this stage you could say, okay, I'm happy with that, or maybe I want to iterate. Maybe I say 1.2 meters is a bit coarse. I'm going to go and solve something a bit finer, so I can cancel this. I can maybe change my mesh settings, and I can change it to moderate. Get a new estimator, and you can see here that now we've got a much smaller cell size, and the resources have gone up a little bit. And if I'm happy, I can actually start that simulation, rename it as appropriate. Now, it's important to note that all of these wind directions that you've asked to be solved is solved on a separate machine, a separate instance, which means that this is additionally sped up. As we mentioned before, each individual wind direction is solved on a GPU instance, because this is a GPU accelerated solver. And of course, if you wanted to solve as many design iterations as you want in parallel, then you can, of course, duplicate the simulation, change the geometry, and refire the simulation as many times as you like. And when you've got a simulation that is complete, you will get an email, of course, to tell you to come and assess the results. And it's then that you can start looking at the results and coming up with design decisions like we did in the presentation.
Thank you, Darren, for your great presentation. Very insightful. And I really loved that it was such a hands-on example. So we don't have much time left, but would be happy to answer your questions now. If you haven't put any in, like you can use this time now to add your questions, but we can already start in the meantime to answer the first couple ones. Let me start with this question here. Can I simulate the wind speed results of a certain day or time? Yes, so the approach is that we're doing analysis on multiple wind directions, as Darren showed. And basically, if you know the wind direction and speed of a specific day and time, we got you the individual results for each wind direction. So you can go there and open these results up. And then you can also scale the wind velocity to the actual velocity that you get from your weather data for the specific hour that you're interested in.
Yep. Thanks, Richard. Maybe I can pick up one of the next questions. So it seems like there are repetitive questions on people using community version and they couldn't figure out how to use this pedestrian wind comfort or PWC simulation. That's a good question. So the PWC analysis is available only on the professional subscription. And if you wish to actually make use of this wonderful tool and make design changes in your architectural domain, then feel free to actually contact our sales team. You can reach out to them via email at sales@simscale.com, and we'll be happy to actually talk with you on the requirements and then activate this pedestrian wind comfort. And otherwise, if you're already a customer of SimScale, you can simply contact your customer success manager, one who is responsible for your account, and we can actually activate it on the background.
Yes, there's one other question regarding the nice compare functionality, and the user doesn't seem to be able to find this. As Darren mentioned, the compare functionality is currently in beta mode, but if you're interested to test this, let us know during either the direct chat in the tool, or you can directly also write here to sales@simscale.com or product@simscale.com, so we can enable for your account the feature, and then you can test it. So we have a system where different features can be enabled or disabled that are currently in the beta stage, and you can test them, and we would be happy to receive your feedback how it's working.
Yeah, probably due to the time, I'll pick up the last question for today. So one of the users asked about how can you share a project between colleagues? That's a good question. So since SimScale is a cloud native simulation tool, you might have seen what Darren shown on the browser itself. You'll be able to actually share your project with your colleagues by simply sharing and then entering their email ID, which is used for SimScale account. And you'll be able to actually collaborate at 3 different levels. Either you can give a copy, a view, or an edit access to collaborate and then work on the same project within your team, or if you want to send that project to your clients as well.
Great, thank you, Ajit. We are already short on time. For the follow-up questions that are not yet answered, we'll answer them directly to you. And with that, thank you, Ajit, for joining us. Thank you, Darren, again for the great presentation. And to the attendees, I hope you got some good insights from the webinar. If you're interested to talk to us directly on your specific requirements, you can just write an email at sales@simscale.com or visit the site and get yourself an account and try it out, or just join us for the next webinar that's coming up soon. So
thanks, everyone.
Thanks, everyone. See you soon.
See you then.